Okay, here we go. All right, so remember, what we were kind of heading towards the whole chapter was understanding reducing, understanding adding and subtracting, understanding multiplying and dividing, all of that really to get to the point where we can do rational equations, and so that's what we need to deal with. So, solving rational equations. Your first aim is to get rid of the fractions. You really want to get rid of the fractions. Which means you're getting rid of the denominators. And you're going to multiply by the LCD. So we want to get rid of the denominators. If we multiply by the LCD, that'll get rid of the denominators. That's going to involve some factoring. And again, some varying complexity. However, remember, whenever you have a variable in the denominator, if it's not an equation, you're going to worry about excluded values. Values the variable cannot be because you end up with infinity. If it's an equation, you're going to have that same concept, only they're going to be extraneous, right? Same thing as excluded, so be careful, and that should be read. Be careful of any extraneous values. Always be on the lookout for extraneous values. So mathematically, you can get a value. The math worked. You did everything correctly mathematically. But if you put that value back in for the variable, it gives you a zero denominator. And again, anything divided by zero is infinity. Now we got a problem, right? Because you're off into infinity and maybe even beyond. All right, let's do a couple examples, and let me try to show you some of the situations. Whenever you have one fraction on the left and one fraction on the right, there's really a shortcut that can be done that makes it to where you don't have to worry about the LCD. It is the LCD. On something like this, the two denominators are different, correct? So the LCD, remember, the left side, the x and the -6 are tied together, right? They're one thing. They're a binomial. They're together. One quantity. And on the right, you got a 5. So the LCD is really x minus 6 times a 5. So don't write this. So if you multiplied the left by the LCD, you would do this. And if you multiplied by the right by the LCD, you would do that, correct? Again, don't do this. And so then you would end up getting rid of those there and getting rid of the 5 there, and that's what you'd be left with, right? And you would finish it out, and that is multiplying both sides by the LCD. So the shortcut on this is whenever it's just a fraction on the left and just a fraction on the right, remember, things on the bottom go to the top across the equal sign. That you can write. It just saves you a step here. And then the 5 on the bottom on the right goes to the top on the left. It's the exact same thing as multiplying both sides by the reciprocal. It's just that you don't have to write what's going to end up dividing out. Okay, so we end up with 15 on the left and distribute on the right. So you got a 2x minus 12. So move the 12 to the left, divide by the 2, and you're at 27 halves. XX, that was good. Gonna X it out. So you get 27 halves equals x. And the only problem with x was if x were a 6, correct? 6 would make the denominator 0, so 27 halves is good. We're happy with that. Everything's fine. Everything's dandy. The world is grand, right, Destiny? Yeah, absolutely. Even in the world you were in, right? All right, let's do another one. Never, Neverland. I don't know where you are. All right, so same scenario here. And you could right off the bat, go ahead and just multiply across. This one's a little different in that, you know, it would really be nice to know what in the world this trinomial factors into. Because if for some reason it factors into something that is a factor on the other side, we could maybe save a step or two or make it less complex. So we need to factor. And hopefully you're getting faster at your factoring right now. And this is what, a -4 and a +3. Again, I always look at the back first because I'm always looking at my outers. And hopefully everybody sees the common 3 on the right-hand side. So if you then use the LCD, you'll just save yourself a little bit of hassle. It'll be a little bit less work because more things are going to divide out. So on the left-hand side, right, the LCD is 3 times x plus 3 times x minus 4. Do you agree that's the LCD? 3 times x plus 3 times x minus 4. And if you do the same thing on the right, 3 times x plus 3 times x minus 4. So you can see on the left, both of those go away, which makes the left a little less complex than it would have been. And on the right, one of the x plus 3's and the 3 go away to make the right less complex than if you just move things from the bottom to the top. I mean, you can, and it'll work. It's just you're going to end up with a lot more work in the long run that way. So now you got to distribute. Be careful. You might want to put this x minus 6 in a parentheses because it is that 3 that's left times that numerator. Does that make sense? Right? It's the 3 in the top left times that x minus 6. So we get a 3x minus 18 on the left. And then we got to distribute x minus 4 times 2, and you get, what, a 2x minus 8 on the right. And then just go ahead and finish this thing out. Move the 2x to the left. Positive 18 to the right. What do we get? X equals 10. And is it okay if x is a 10? Yeah, as long as x isn't a -3 or a +4, we're good. And x equals 10, and everybody's happy. You happy? Luke's not happy. Leah's not happy. Is it because you're just not a happy person, or you're not happy with the math? Oh, you don't like math. The math was okay. Tisk tisk. Math makes the world go round. You know that, right? Come on. All right, let's do the last one. So here, obviously, you have multiple fractions, and you're definitely not going to do any shortcut here. You're just going to multiply by the LCD every term. So your first thought has to be, what is the LCD? And not the liquid crystal display. It's old school. Real old. No, not really. So, do you have the LCD? You know, hopefully you're at the point where you can look at the 3 denominators and say the LCD is what the LCD is. The LCD is. And if you can't do that, this is what you got to do. Off to the side, you got to say the first thing is an x. A 6x squared is a 2 times 3 times x, and a 3 is a 3, and therefore the LCD is a 2 for the 2 column, 3 for the 3 column, x for the x column, x for the x column, and you have to say the LCD is 6x squared. Okay. So if you can't look at it, then you got to go that route, right? How we learned how to do LCDs back in Algebra 1. Depends. If you can look at it and say, oh, it's 6x squared, then great. 6x squared times that, and 6x squared times that, and 6x squared times that, right? That's nice in the middle. And that's a 2 there. And now you got to see where you're at. So what is that? 24x plus 5 equals negative 4x squared. And of course, now you say, oh, it's quadratic. And then your brain says, can I take the square root of both sides? Or can I factor set it equal to 0? Or do I have to use the quadratic equation, right? And that's what you're thinking. So let's move the 4x squared to the left, making it positive. Plus 24x plus 5 equals 0. Does this thing factor? You have 2 and 2 or 4 and 1. 4 times 5 is 20. I'm factoring, right? You follow? I'm doing it all in my head. 4x and x. If I put the 5 there, I get 20, but I don't have enough to get to 24, right? And that's the only way you're going to be close. And if you do 2x and 2x and you put a 5, you got 10, but you're not going to get enough either, right? Doesn't factor. All right. Everybody remembers the quadratic equation, so belt it out. And we're not going to finish this one. But if you did, you would end up with negative 6 plus or minus the square root of 31 over 2, I think. Okay, I think. But everybody remembers negative b plus or minus square root of b squared minus 4ac all over 2a, right? Quadratic equation. Quadratic equation, quadratic equation. Okay, so here's a beefed up model of that previous one, right? This one's a little bit beefier. But it's really not that bad because if you factor this middle denominator, it's a difference of 2 squares. And so thankfully, it's not terrible. So now hopefully you agree the LCD is just an x plus 2 times an x minus 2, right? And that's what you got to multiply everything by. It's got to be every term. If you have 3 fractions on one side, then it'd be times all 3. Every term on the left, every term on the right. So now she turns out to be not all that bad. None of the examples I gave you today are going to have extraneous roots. Just be careful. Sometimes you will. And there's no way I can show you every different variation, but it's the principle you have to learn. Get rid of the denominators and then solve the resulting equation. If it's quadratic, solve it as quadratic. If it's not, solve it as a linear. Oh, we get 4x plus 8. Hey, be careful with this negative, right? It's got to be distributed. So this is a negative x plus 6. And on the right, what, a negative 2x plus 4? So we end up with 5x when I get all my x on the left. 8 and 6 is 14. Negative 14 and 4 is a negative 10. X equals negative 2. I don't like that. Is that it? Negative 2? Did I miss anything? 4x, 8. Negative x plus 6. Negative 2x plus 4. Add the 2, 6. Everybody good with that? All right. And can x be a negative 2? Can x be a negative 2? So this thing is extraneous. I just got done saying I didn't give you any extraneous, and the last one was. All right. X can't be a negative 2. That would give you infinity as the denominator in that middle fraction, and you got to get rid of it. No good. She's a no good. She's a no good. Dolores.
Why if it is 5x, it is 4x minus x?
So 4 of them minus 1 of them is 3 of them. But now I got to add a positive 2x to both sides and move that to the other side. Anybody else, any other questions on that? And again, why is it extraneous? Because of the circled one, x plus 2. If you put a negative 2 in for the x, you're going to get 0 right there in that term, and that's no good. Okay. So again, on these, you always have to check. There are a few instances where it'll be quadratic. You'll get 2 values off the quadratic. You'll be able to factor and solve, or quadratic equation. But usually it's when you factor and solve, and one of them may be bad and the other good. It's possible. So you can have more than one solution, and one of those solutions can be extraneous. You get rid of it, keep the other ones that are good. This one, the one solution we got was no good, and that's it. Okay. Work problems. These are pretty easy. Not a whole lot to them. And you use a total equation, so you're going to add things up, and it's going to equal a total. And the equation involves the reciprocals. That's why it's in this section. So we're talking about work together problems, machines doing the same, working on the same problems, stuff like that. You know, computers have quad processors these days and whatever, more than that I would guess, but you know, they're working on the problem at the same time, and therefore then you save time. All right, so simple example, John can mow a lawn in 40 minutes. Ted takes 50 minutes, but Flash can mow it in half an hour. How long will it take if all 3 work together? Now, just logically looking at the problem, the answer definitely has to be less than, it's got to be less than 30 minutes for sure, right? Because Flash all by himself will take 30 minutes. So we better get an answer less than 30, all right? We have to. All right, this one has 3 guys. So I'm going to set up 3 reciprocals. And then the right-hand side is the reciprocal of the total. So that's how all these go. You set them up as reciprocals. And so we'll make the first one John, and he was 40 minutes. And then Ted was 50. And then Flash was 30. Go Flash. So now it's just, and to the right would be 1 over X, right? Because we don't know what it is. N, Z, Q, whatever your favorite letter is. Knock yourself out. Destiny said D. Match your grade, or is that something else? I'm just wondering. All right. Just curious. All right. So how would you finish it? You just look at it and say, hey, it's one of those problems where the variable's in the denominator. We want to get rid of the fractions. We're going to multiply everything by the LCD. And therefore, the LCD on this thing is... What can you get to? What in the world is the LCD? You got 40, you got 50, and you got 30. 150 is not going to work, right? I think you got to go all the way to... Well, can we get away with 300? No, I think we got to go all the way to 600. Not a big deal, right? Oh, wait, is a 40 going to get us to 600? Mm-mm. Yeah. 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 You can always do the LCD chart. All right, 600, right? 600, 600, 600. Oh, by the way, X, 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 X. Don't forget the X, 600X, right? Gotta take care of all the denominators. 40 goes in, 4 goes into 60 how many times? What is that? 15, right? Beautiful. 15x. 50 goes into 600. 12x. 30 goes into 620x. And then we still have, what, 600? All right, and so solve that. Not a big deal. What's that? 35, 45, 47x equals 600. So divide the 600 by 47. Break out the calculator. All right, so I just add it like terms. All right. Move to 47. Grab my calculator. Punch it out. And the total time is 12.8 minutes. All right. And that makes sense. It's got to be over 10 minutes because 3 flashes would have done it in 10 minutes. And the other 2 guys were slower than Flash. So 12.8 and voila, you are there. Not bad. Not horrible. The LCD was a pain there, but that wasn't horrible. All right, let's do one more. I was going to do a computer clock time one, and it was too much of a pain with the numbers, so I gave up. Left the chips there. Okay. Last one. Lee can paint the family room in 6 hours. If Sue helps, they can get it done in 4. At this pace, how long would it take Sue to paint the room alone? Sue alone. All right, so you got 1 over Lee plus 1 over Sue equals 1 over the total, right? Again, it's a total equation. This time we only have 2 people. 1 over Lee plus 1 over Sue equals 1 over the total. Lee is 6 hours. Sue is, who knows, X. But together it is 4 hours. A little bit easier LCD on this one, right? Hopefully everybody agrees it's 12x on this one. All right, finish it out. You can finish it. Finish it out. Sorry, Sue. Sue is slow. Sue is so slow. Sue is like really slow. Sue is a perfectionist. She's trying to be artistic. Lee just wanted to get the job done. All right, be careful with these. These are a key concept of the chapter. So make sure you're doing well with them.